To warm up, we're going to find the length and width of each rectangle. The width must be the greatest common factor of the area. Our first term is 12r and our second term is positive 18. The first thing I look for is the variables. Does each term have a variable? No, it does not. So there will be no variable in my GCF. Now I look for what is the greatest common factor as far as the numbers are concerned. So 12. So what is the largest number that goes into both 12 and 18? That would be 6. So 6 will be our GCF. In order to find the length of this rectangle, we divide each term in the area by the GCF. 12r divided by 6 is 2r. 18 divided by 6 is positive 3. Now we're going to check by distributing. 6 times 2r is 12r. 6 times 3 is positive 18, and that is our area. In number 2, our first term is 24x, and our second term is positive 72. All right, so our GCF is 24. To find the length, we'll divide each term in the area by the GCF. 24x divided by 24 is 1x, or simply x. Positive 72 divided by 24 is 3. And let's distribute, multiply to check. First thing I'm going to check is, do they have a variable in common? Ooh, this term, 4b squared, has a b times b, and this term, 14b, has a b to the 1. If I were to expand those, I would get 4 times b and 14 times b, just expanding the variable portion. So the question is, b to the power of what is in common with each term? This term has a b to the power of 1. So what's in common is b to the power of 1. b to the power of 1 has to be a part of your GCF. The GCF involves the variable as well, not just the numbers. But what about the numbers? Is there a number that's in common with 4 and 14? So it looks like our greatest common factor, as far as the numbers is concerned, would be 2. All right, the GCF of this rectangle area is 2b. Let's find the length. 4b squared divided by 2b, that's going to be 2b, but I'm going to expand it to show you. I know that 2 actually goes into 4, so I'm going to rewrite 4 as 2 times 2. That's equal to 4. And then I'm going to rewrite b squared as b times b. That's equal to b squared. All right, 2 times b divided by 2 times b. We have some common terms in the top and the bottom that can reduce to 1. b over b is 1. 2 over 2 is 1. And so we are left with 2b times 1, which is just 2b. Okay, so that is how you can visualize. You can expand to visualize when you're dividing. Yay! First, I check to see if there is a variable in common. Yeah, it looks like 4 is the largest number that goes into both 20 and 36. So we will put 4 as the number part of our GCF, which makes our GCF 4a. Let's check. Uh-oh, I see 4 terms here. How do I factor this to find its length and width? This seems like a lot to handle all at once. So to begin, I'm going to break it down into 2 groups of 2 terms. So you'll have one group is the first 2 terms, and then my second group is the second 2 terms. And now I'm going to factor just these groups, factor just 2 terms at a time. So it's as if we're going to put put that piece on hold and just look at 4b cubed plus 28b squared. Can you find the GCF? When I expand the variables, I get 4 times b times b times b. This one is 28 times b times b. So to check first, I'm looking at b to the power of what is in common between the two terms. And I have b times b in the second term and b times b as well in the first term. So the most b's that are in common would be b to the power of 2. So b squared will be a part of this GCF. And as far as the numbers are concerned, I know that 4 actually goes into 28, and 4 is definitely the largest number that goes into 4. So 4 is the largest number that goes into both 4 and 28. So that will be a part of our GCF. 4b squared is our GCF for this first group. What do we have when we divide that GCF? Well, 4b cubed divided by 4b squared is simply 1b. 28b squared divided by 4b squared is 7 times, well, b squared over b squared is 1, so 7 times 1, that would be 7. All right, now we're going to factor the next group, 3b plus 21. What is the GCF of 3b and 21? Okay, after we factor out or divide each of these terms by the GCF of 3, I get 1 times b, and 21 divided by 3 is 7. Now we did separate these groups so that we could look at them 2 at a time, but this is still one problem. So I need some sort of a sign here. Is it positive or is it negative? Well, our GCF was a positive 3, so this should be plus 3. It's really important for us to notice that this right here is a product. We're multiplying 4b squared times the group b plus 7. And this right here is also a product. You're multiplying 3 times the group b plus 7. So does the first product and the second product, which we're adding together, do they have a greatest common factor? Do they have a GCF? Do they have something in common? Yes, they do. B plus 7. A GCF can be one term, it can be a number, it can be a variable, it can also be a group. And in this case, B plus 7 is the GCF of these two products. So this time, our GCF is a group. And whenever we have a group, we have to put parentheses to let people know it's a group. And now, how do we find what's left after you divide the GCF? Okay, well, let's divide these two products by our GCF. B plus 7 over b plus 7 is just 1. So 4b squared times 1 is 4b squared. B plus 7 divided by b plus 7, that's also 1. And 3 times 1 is 3. So is this our answer? Well, this product must equal our area. So we have to multiply to check. And notice that it is a product. It is our length times our width. There's no plus sign in between the parentheses. We have completely turned this sum of 4 terms into a product, which is the goal of factoring. So now we're going to check, and you can either check with double distribute or the box, whichever you prefer. Is that the same answer as we have here? Well, remember that addition is commutative, meaning 2 plus 3 gives you the exact same answer as 3 plus 2. So we can actually rearrange our terms. 4b cubed, and then instead of plus 3b, we'll say plus 28b squared, and then we'll add the 3b, and then add 21. Yes, that is definitely the length and width. So now we will write them on our rectangle. b plus 7 and 4b squared plus 3. Here I see our area has 4 terms. So I'm going to begin my factoring process by grouping. I'm going to group the first 2 terms, and I'm going to only factor the GCF out of those. And then I'm going to group the last 2 terms, and I'm going to factor the GCF out of those. So what is the GCF of 18n cubed and 42n squared? First of all, the GCF should include n to the power of what? That should be n squared, because this is n times n times n, and this is n times n. So the most they have in common is n times n. But what is the largest number that goes into both 18 and 42? That should be 6. What do we get when we divide each of these terms by the GCF of 6n squared? Time to find the GCF of the second group. I see here there's an n to the power of 1, but here there's no n at all, so n is not a part of this GCF. Let's look at those numbers. Okay, so looking at the factors of 15 and 35, I see that 5 is the largest number that goes into both of those terms. But there is something very specific about grouping. Whatever this sign is, has to stay. So if this is a minus, then our GCF will be a negative number. Ooh, okay. So instead of our GCF being 5, our GCF will be negative 5. This is weird. Be careful. This subtraction changes some things. So we're going to divide each of these terms by their GCF, which is negative 5. Negative 15n divided by negative 5 is positive 3n. Negative 35 divided by negative 5 is positive 7. And that's the very tricky thing to remember, that if this sign is a negative, it has to stay, which will change the sign of your length portion. So now I have the difference of 2 products. That is not factoring, okay? I need simply a product as my answer. And here I have a difference of 2 products. So I need to keep going. So is there a GCF between product number 1 and product number 2? Yes, there's an entire group. That is the greatest common factor. This whole grouping is the GCF. So I'll write 3n plus 7. Now to find out the other part of my finished product, literally, I'm going to divide each of the products, product number 1 and product number 2, by the GCF 3n plus 7. When I divide the first one by 3n plus 7, 3n plus 7 over 3n plus 7, oh, that's 1. That is also 1. So I have 6n squared times 1, which is 6n squared, and I have negative 5 times 1, which is negative 5. This should be my length and my width. But I gotta check. Woo woo. All right, so our length and width are 3n plus 7 and 6n squared minus 5. And now it's time for you to try. All right, and when you check, you should get p plus 8 and 7p squared minus 4 as your length and width. All right, let's try a challenge. There is a GCF. What are you talking about? There's always a GCF. No, I mean not in the first two terms in the first group and in the second group. I mean that all 4 terms have a GCF, 15, 60, 24, and 96. Well, I know that the GCF doesn't have a variable in it because our last term does not have a variable. So let's see what our factors are. Check to see if you got all the factors. Okay, so I'm going to look at the smallest number, okay, because the GCF is not going to be a number that's bigger than 15. Does 15 go into all of these numbers? 15, no. So it's going to have to be smaller than 15. It looks like my GCF is 3. I believe 3 is the largest number that goes into all 4 of these terms. So what do we get when we divide each of these 4 terms by our GCF of 3? Well, we get 15n cubed divided by 3 is 5. N cubed plus 60n squared divided by 3 is 20n squared. Negative 24n divided by 3 is negative 8n. And negative 96 divided by 3 is negative 32. Now, I know that 3 is not my entire width because here I have 4 terms. I'm pretty sure that I can factor that by grouping. So 3 is just going to be part of my width. So I've taken our GCF of 3 and I made sure that it's taken into account as part of our width so we do not forget. So now it's like this is the rectangle that I'm finding the length and width for. Go ahead and do this and check with your teacher later. So to recap, what is this method of factoring called? Factor by grouping, where we take these 2 terms and we factor out their GCF, and then we group these 2 terms and factor out their GCF. And when do we do this? When we are given 4 terms. That's when we use factor by grouping.